Ella Physicists, what's the crack? So today what we're going to do is just a 1-mark question. It's a multiple choice question. What we're trying to figure out is where the electric potential between these two charges is 0. Okay? Even though it's a 1-mark question, it's quite good for the math. Okay? So again, if I've got a larger charge here, 6 microcoulombs, and a smaller charge here, 4 microcoulombs, I know that the equipotential, the point where the electric potential is 0, is going to be much closer to that 4 microcoulombs charge, okay? Because it's a smaller charge. So what I want to do then is I want to look at the equation that's got electric potential in it. And my equation for electric potential is 1 over 4 pi epsilon naught Q over R. Okay, so I want to find where the electric potential is 0. So that means the electric potential due to the negative 6 microcoulombs is going to balance that to the 4 microcoulombs. Okay, so what I'm going to write now is my electric potential is 1 over 4 pi epsilon naught times by 6 microcoulombs, so 6 times 10 to the negative 6, divided by R, so the distance between them. So I'm trying to find the distance between P to point X. So let's say we represent that as X. That means from X to Q, the whole thing is 120, must be 120 minus X. Okay, but just remember that's in millimeters, so it's actually 120 times 10 to the negative 3 minus X. Okay, so the distance here that I'm going to use for point P and point X is just my X. And then I set up another equation for this charge. So V is 1 over 4 pi epsilon naught times by Q, which is 4 microcoulombs, divided by the distance between them, which this time is 120 times 10 to the negative 3 minus X. Okay, so what I want to find out is when this point is 0, the electric potential is 0. So it's when these two potentials be equal to each other. So I equate these two lines to each other. My 1 over 4 pi epsilon naught will cancel because it's on both sides. So what I have then is 6 times 10 to the negative 6 over X will equal 4 times 10 to the negative 6 over 120 minus X, or sorry, because it's in millimeters, 120 times 10 to the negative 3 minus X. Okay, so if I cross multiply, what I have now is 6 times 10 to the negative 6 times by 120 times 10 to the negative 3 minus X is going to equal 4 times 10 to the negative 6 times by X. Okay, so all I want to do is factorize out these brackets now. So I factorize the brackets, it's going to go down. I've got 6 times 10 to the negative 6 times 100 times 10 to the negative 3 times by negative X times by 6 is going to be negative 6 times 10 to the negative 6 times X equals my 4 times 10 to the negative 6 times X. Okay, so if I take my negative over the magic bridge, that one becomes positive. So what I'm going to do now is 6 times the negative 6 times 120 times the negative 3 divided by 10 times 10 to the negative 6 to get my X. So if you do it in the calculator, I've got 6 times 10 to the negative 6 multiplied by 120 times 10 to the negative 3. I need to divide that number by 10 times 10 to the negative 6 to get a final answer of 0.072 meters, which I know is 72 millimeters. Okay, so the distance between P to X is going to be my 72 millimeters. So that's grand.